Well, hello. We are going to move on to section 2.3 today, which is still dealing with square root functions compared to with a linear function. And today we're going to look at solving equations that involve both root functions and linear functions. Firstly, we're going to look at a root function, which we know looks like that. And we're also at the same time going to look at a linear equation, which looks like so. So what we have is that yellow equals green. So what will it mean to solve this equation? What will the solution look like? Graphically, what it means is if we were to draw one function over the other, scales are not exactly the same, but pretty close. We're looking at where they would cross. Where are they equal to one another? And specifically, we're looking at the x-coordinate, where they're equal together. Algebraically, we would want to isolate the x value. And that's what we're going to be doing, is both those graphing and algebraically. So graphically, we could see there when we have that overlap, where is the answer? Well, difficult to assign an exact value because where they cross isn't on one of the corners of the squares of the grid. So that means we need to have a different strategy. And this is one strategy that works. And it's basically simple algebra that you've done before. First, we're going to square both sides. And the reason we're doing that is to eliminate the square root on the left-hand side. So when I square a square root, I am left with 2x minus 1. On the other side, I need to make sure to do the multiplying a binomial times a binomial. If I don't remember to do that, I would probably write down this, which would not be correct because that is not taking into account all the multiplication that happens there. You would actually get x squared minus 2x plus 1. Now, in order for us to solve this, if we wanted to, we can actually graph this parabola and this line and see where they cross, but it's going to be the same solution that we just saw. It'll be a value that'll be difficult for us to determine from the graph. So instead, we're going to make this equal to 0 by adding 1 and subtracting 2x from both sides. So when I subtract 2x, I get negative 4x, and when I add 1, I get plus 2. Now this is another parabola, and really now what we're looking at is where are the x-intercepts of this parabola. And again, we could graph it, but we already know the answer is going to not be an even number, so where does that leave us? I don't know if you guys remember or not, but if something is not factorable, and I'm saying that because I can't think of anything that multiplies to 2, that will add to minus 4. That leaves me with a couple options. One is the quadratic formula, and the other is completing the square. I'm going to use the quadratic formula, which tells us, therefore, that x equals, if we assign a value of the number in front of x squared is a, the number in front of the x is b, and then we have c, where the quadratic formula tells us that x would equal minus b plus minus the square root of b squared minus 4ac, all divided by 2 times a. In this case, minus b would be 4, plus or minus the square root of b squared would be 16. 4 times 1 times 2 is 8, all divided by 2 times a, which would be 2. And just simplifying that, 4 plus or minus the square root of 8 over 2. Well, the square root of 8 is 2 root 2. And so now we can divide everything by 2, and we get this as the answer. Now, let's go back to our original expression here, our original graphs. What does that mean for us? That means that's where they cross. Now, it appears here that there's only one answer. Here, we have 2 answers. Which answer is correct and why? That's the question. If we go 2 plus the square root of 2, I don't know the exact value, but it'll be 3 point something. If I do 2 take away the square root of 2, it'll be 0.7 or something along that lines. And you can see here on the graph that that would be the the answer that we would select. So we have to consider, even algebraically, which answer would make the most sense. So when we come to class, we'll talk about this further, and we'll use these slides to illustrate some of the main points. As long as you got the basic idea, that's a good start, and we'll sort out the details together in class. So that's it. I will talk to you again.